Okay, so back for another Lab 1 video. In this one, we're gonna delete the nulls. Notice there were some nulls in this precipitation data, and we'll do that prior to then doing interpolations, and then we'll do some visual comparison between the interpolations of 1 year's precipitation versus the climate normals. Okay, so first, how would we delete these null values? So we could do that a number of ways. We could do a selection by attributes. So we can select new selection where precip is equal to null. So how do we get that? Or maybe it's is null. Yes, it's is null. Apply. Okay, so that gave me 20 of 291. And so I can select the smaller subset of those here. And there they all are. Now, one thing I can do is just delete them. If you don't want to do that, another way would be to go back to the overall view and make your switch your selection so that all the ones that aren't null are selected. This might be a safer way to go than deleting stations. And then you right click again and we'll export our features and we'll save it as Utah rain data 22 no nulls. If that works. No, I don't like that. Too long, probably. Utah, 22, no, Utah rain, 2022. And then I'm going to call it NN for non-null. Okay, that should be okay. So I'll do my interpolations on that non-null data. Okay, so I'm going to clear my selection now. And so hopefully you can follow that forward. We go over to 2022. Let's see if any of those are null. So we'll go new expression where precip is null. Okay. Oh, I didn't think I said add to selection. Let's clear. Let's try this again. Select 2021, select by attributes. Oh, here we go. Selection type. You kind of want the default to be new selection in most cases, but I could change that, I guess. Is null. Okay. 18 have been selected. There they are. So yeah, not quite the same, but similar number. So again, I'm going to switch the selection and I'm going to click on the Utah Rain 2021 data export features. Now I'm going to call this one Utah Rain 2021 non-null. Okay, good. I'm going to remove the things I'm not using anymore. Not the normals, I'm still using that. Remove. Okay, and then the other thing I have is my normals, right? So maybe I should check on them. There's my normals. They don't, not everybody overlaps in every location here, right? So that's another interesting thing we have about our data. Some of them are going to be covering different positions than others. Yeah, let's look at that attribute table. So do we have any nulls here? Let's just sort these things. And then I'll scroll through. Yeah, no nulls there. Okay, so I will leave that as is. Turn that on. Okay, so there's my data sets. Okay, so close these things. I'll make this a little smaller. Don't have to look at all that. So interpolation. So to do your spatial interpolations, you'll need to make sure some of your tools are working correctly. And then interpolation. Where do we need to hunt for that? I have to remember. Okay, so I believe we want to be under spatial analyst for some of this, but for do something like tin, you do 3D analyst. And surface and or is it spatial statistics? No, it's right here. It's its own thing. Interpolation within spatial analyst tools. So we can get inverse distance weighting, Kriging, natural neighbor, spline, etc. So IDW might be nice in some cases. One thing that I think everybody's going to want to do these interpolations well will be a shape of the state of Utah. So because if we go to IDW, I believe that we can input a barrier polyline feature right here, which will, so if you had like a feature of the state of Utah, put it there, it might limit the output area, or maybe it's a mask, sorry, that you want. But there's some way that you can kind of basically use this as like a cookie cutter, your interpolations only over the state of Utah. You don't have to do that, but it could be something that you want to do. So you may want to go to UGRC and get yourself a state of Utah to do that with. You don't have to, but that's a suggestion. Not every one of these is going to have that option, but some will. And yeah, if you really want to compare well to, like, for instance, that thing, that might be helpful. Okay, so yeah, let's try an inverse distance weighted interpolation, and we'll do it for a couple of these and see how things look. Okay, so input features. So let's first do the normal. So with any of your interpolations, the Z field is really going to matter. And what you always want to make sure is it's whatever you're trying to interpolate, which is your precipitation in this case. A lot of times the default is going to think you want the elevation, but that's not what you want here. You're not trying to make a DEM. Okay, so the output cell size, you can see here, is tiny. That's because, you know, the coordinate system is what it is. It's using, it's in a geographic coordinate system. And so the cells are in decimal degrees. And so it looks tiny, -2, but it's not actually. So, yeah, and so it's converted the units for you. And so you could go with the default. You could do a couple of different things. So you could make the output coordinate system be something else. So if you don't like working in that, you could make the output coordinate system UTM NAD 83 zone 12 north, which is Utah. And then I think if you go back to the parameters, you'll see your output cell size now is about, this will be in meters. So this is 1.78 kilometers. And, you know, that's kind of arbitrary. So maybe I would make that, I don't know, 1,000. Oh, it's not letting me do that. Oh, I see. It's based upon your choices here. So I used a power of 2 search radius being variable, and then it gives me an output cell size. I see. And so it's looking for at least 12 points to do the IDW. Okay, so, we could run with that if, let's see what happens. Okay, so there's a map of greater precipitation. We can see it in the Uintas. This is for Utah normals. Yeah, and you can see that it is an IDW. You can see isolated points of higher precip and lower precip. Lower is green in this case, higher is these colors. You can change that, of course. You can change how this is displayed. It's classified now. You could stretch it. Okay, so that was run for the Utah normals. Could run it for 2021. Keep everything else the same and see how different they look. Yeah, I should have been careful about what I called that first one. Oh, it was norm 1. That's fine. And we want to make sure this is Utah Rain 21 IDW. That sounds good. It failed. Ooh. Let's try this again. Oh, we had to change this Z value to precip. Because it's a different table. It didn't quite recognize that at first when I just changed the input point feature. Now it might work. They have a similar pattern, right? But they're definitely different interpolations in the overall scheme of things. So we can do a visual comparison, right, between these things. We can see a couple of other things that took place here, right? The width of these things is different. We turn on the normals versus the 2021 symbols, which is these open circles. We can see in some cases the open circles aren't over here, and yeah, the data set just doesn't go as far over there. So some things will be different because of that. It doesn't quite fit the state boundary. Like I said, you can try to force that to occur if you wanted to. Okay, so that would be one way to go about things. And you can do this for different interpolation methods. Now, when you do your tin, you're not going to be able to force it to any shape, and it's not necessarily going to make kind of square boundaries or anything like that. It's going to be a linear interpolation, no more than the extent of the data sets, and so it'll be a triangulated mesh, basically. So keep that in mind. Okay, so I will stop this video, and in the next video, we'll think about some ways to quantitatively compare these interpolated results, but maybe also just the original data too.